architectures we've used for decades and decades are no longer holding true. So we have to come up with new innovative ways of doing things.
Startups really is best known in bringing fresh perspective and disruptive technologies. And they usually can focus more on niche market as they develop novel chip architectures, introduce innovative business models.
So I feel in the semiconductor domain will benefit from government involvement in kind of lowering that risk bar and encouraging a common vision for the industry to rally around.
Hello and welcome to Connected. I'm Divya Gopalan. Now, a whopping 1.4 billion smartphones were sold last year, as were 252 million personal computers and nearly 87 million cars, not to mention tablets, gaming consoles, and various home appliances like microwaves. What do they all have in common? Semiconductors. They all run on microchips. They get faster as they grow smaller. And as global demand keeps rising, the supply is trying to keep up. And Taiwan is one of the key links in that supply chain. So nearly 85% of the chips sold globally go into some consumer-grade device or appliance or vehicle. The total global semiconductor market, by the way, was worth $574 billion in 2022. Its value fell slightly to $550 billion in 2023, but it is expected to break $600 billion this year. And to help us understand what's next in chips, the advances and innovations that we can expect in the industry, we're joined by Mavis Ho in Taipei. Now, she is the General Manager of Strategic Partnerships at Imec for Asia Pacific. Imec is among the world's R&D leaders in nanoelectronics and digital technologies. And joining us from Toronto, Canada is Niraj Mathur, who is co-founder of Blumind, a VC-funded startup focusing on analog AI chip design and system solution. It's great to have you both on the program. Now, I'm going to start with you, Mavis. One of the things the pandemic highlighted was the importance of semiconductor supply chains, as well as the challenges in capacity. Have the rules of the games changed for the global chip industry? And do we need a new approach to R&D, production, investment, or industry growth overall?
Certainly, I think the field of semiconductors is, of course, constantly evolving and even more so post-pandemic. And to adopt such a rapidly changing landscape, I think developing new modes of tech development and market growth became very critically important. And I think this involves a variety of approaches, such as collaboration between semiconductor company, research institute like IMEC, and also government bodies as they foster knowledge sharing, resource pooling, collaborative research and development effort, and working together, of course, we can collectively addressing the emerging challenges. A few other, I think, approaches like focusing on emerging technology like AI, which is so much discussed, the quantum computing. Those technology has significant potential for growth and really drive the demand for advanced semiconductor solution. And I think embracing diversification such as automotive, healthcare, renewable energy, those also definitely can help to mitigate risk and leverage growth opportunity in various sectors. I think last but not least, investing talent and education, because this is something that this includes like creating partnership between industry and academia, establishing research center and promoting STEM education. Those really can strengthen the talent pool through various education and skill development. Those are all really approaches that I think we all need to take serious going forward.
Right, Niraj, as an entrepreneur, you always have to stay one step ahead. What do you see as the next big shift in the semiconductor industry?
Well, let me just start by saying, Divya, that this is an extremely exciting time to be in this industry. After coming out of a period where we had a little bit of a doldrums from the years 2005 to 2015, I call it kind of a lost decade in semiconductors, where really we were commoditized, right? It was all about pricing. It was all about offshoring. Mark Andreessen famously said in 2011 that software is going to eat the world, right? So semiconductors had fallen out of favor for venture capital and really innovation. And then, something really exciting happened around 2017 or so. There were three macro trends that hit us really hard. One is, as Moore's law, which was true for many decades, started breaking, which is essentially you double the number of transistors on a chip every couple of years, and Dennard scaling, which importantly says that the power consumption for those transistors also stays pretty much constant. Both those laws started falling apart just because we were making these devices too small, and our technology just wasn't keeping up. We were down at the molecular level when we're manufacturing these devices. So that was one big trend. The second trend, Mavis alluded to that, right, with AI, 5G, and a whole bunch of new use cases enabled by these, like robotics, human-machine interfaces, human augmentation, AR, VR, and so forth. These new applications that are really improving our lives, even today, are taking hold, and people are demanding these type of applications to improve our lives. And soon we're finding now, AI is actually eating software, right? So that's another dynamic that's emerged. And so for a startup like ours, we really have to be at the bleeding edge, and it's really exciting, again, like I said, to be in a startup in this era of AI, because all this innovation is being driven down. Semiconductors need to deliver again, and we need to innovate again, which is a really exciting dynamic for us. So that's exactly what we're doing.
And what's hard to get your head around is how quickly things are moving, especially in this innovation space when it comes to technology, AI, and the development of semiconductors. And so, Mavis, who is going to drive this innovation? Who's going to push it forward? Is it governments or institutions like yours, or is it the entrepreneurs? Who is driving this push forward?
Honestly, I think from our angle, the driving force are a joint effort. Innovation always comes from the market demand and for changes and for improvement. So I think all parties can contribute, as like I said, joint effort. So I think starting from government policy drives and foster innovation, such as incentivize research, providing tax benefits, so on and so forth. And then established industry leaders, traditionally they have more resources, expertise, infrastructure necessary to drive that. But I think at this moment, startups really is best known in bringing fresh perspective and disruptive technologies. And they usually can focus more on niche market as they develop novel chip architectures, introduce innovative business models. So the growing demand for advanced chipping sector like AI, autonomous vehicle drives innovation in our industry.
Niraj, Mavis said this. Startups are definitely fueling a lot of the change and innovation, and that's where a lot of the disruption comes from. But what kind of a support do you look for in order to kind of oil those wheels and get that innovation going? Are you looking for, is it the role of the government, or the organizations like Mavis works for, or what is it that helps you or gives you that platform?
Yeah, so it's a great topic, and I agree with everything that Mavis just said. Startups, especially in the semiconductor space, need three things, and we need quite a lot of these three things. Capital, right? We need capital investment, and semiconductor development, manufacturing is very capital intensive. We need talent, right? And Mavis touched on this as well. These are there's a broad spectrum of talent that's needed, ranging from technicians on the manufacturing floor to, PhDs doing advanced R&D. And the third thing we need is a vibrant ecosystem of partners, suppliers, IP vendors, and so forth. So all of those three things are required. I completely agree with Mavis that these three things have to be assisted by government, especially given the big inflection points in technology that we're facing as a society right now, things like Gen AI coming online and so forth. There is a lot of opportunity to provide clarity and vision to the industry and investors as well, so that venture capital and so forth can properly assess risk and properly assess opportunities in this space. So I feel in the semiconductor domains with technologies like quantum and photonic computing, some neuromorphic computing, other areas as well, will benefit from government involvement in kind of lowering that risk bar and encouraging a common vision for the industry to rally around.
Okay, I want to bring your attention to this chart here. This graphic maps out the top 10 trends and innovations most likely to impact the semiconductor industry this year. Now, topping the list, as you can see there, we have Internet of Things and artificial intelligence, followed closely by new materials, chip architectures, and packaging. Then we see 5G, chip design, fabrication, chips for cars, and finally, sustainable manufacturing. Niraj, given that chart, where do you see the greatest opportunity for innovation?
I think today what's driving this is AI very, very, very clearly. This is really stressing the status quo. The architectures we've used for decades and decades are no longer holding true. So we have to come up with new innovative ways of doing things. So on your chart, you had novel architectures, domain-specific architectures, as they're called, more specialization of semiconductors so that we can yield more efficiencies. This is a huge, huge challenge, and I think there'll be a lot of innovation there. To give you a data point that will make you think, we've all played around with ChatGPT. A lot of us are starting to use it very productively in our lives as well. To train a ChatGPT model today takes about $5 million to do one training run, and to have it be production ready and usable by users takes way more than that. It takes multiple training iterations to get this model ready. So $50 to $100 million to train models like this. This is a serious challenge. If we want to have AI benefit our society, we cannot have it be the domain of big tech and big government only. It really needs to be accessible to everybody.
Yeah, so that brings me to R&D, Research and Development, Mavis. Can you tell us what Imec is doing in terms of sustainable innovation?
As you know, Imec is best known for our research in the exploratory research in the process technology in semiconductor. And we continue to provide such solution in this space. So, for example, last year, Imec and ASML announced the collaboration in the next phase of developing state-of-the-art high numerical aperture, extreme ultraviolet lithography pilot line. We call the high-NA EUV pilot line at Imec. And this pilot line is designed to enable the exploration of novel semiconductor application, the potential development of sustainable leading-edge manufacturing solution for chip makers and also end user, as well as the development of advanced holistic patterning flow in collaboration with the equipment and also material ecosystem. Another thing IMA has continued to do is our research into the development of neuromorphic chip, which using spiking neural networks basically is mimicking the way a group of biological neuron operates to perform complex computation quickly and efficiently. So I think it is critical to develop chip technology that can meet those computational demands without depleting the planet's most precious energy resources. So those are just things that we are trying to continue to develop to help this process continue to evolve.
Mavis, that is fascinating and in fact deserves a show in itself. So you've just booked yourself another spot and another show with that. Given that, Niraj, let's talk about how startups are faring. You know, it's hard enough having a startup. It's a daunting environment and such a fast-paced environment when it comes to chips and semiconductors. How are you getting on with getting funding for R&D?
Yeah, Divya, it's been a roller coaster, right? So, the investment into startups really peaked through COVID, surprisingly. And there were, 2021, 2022 were both kind of blockbuster years for IPOs and fundraises. A lot of semiconductor startups got massive rounds of funding due to the massive interest in this industry through the pandemic. All of that is now, got a dose of reality over the course of last year. Investors have become a lot more discerning, and the bar has been raised significantly from where it was a couple of years ago. So I think the rules of being successful in a startup really haven't changed. You got to manage your cash flow solidly. You got to hire the best talent you can, and you got to have innovations that are heavily differentiated and protected from the competition. So the fundamental rules haven't changed. Certainly, the landscape has changed significantly over the last couple of years. The way us at Blumind are dealing with this is we've developed a highly differentiated neuromorphic compute technology, which again is focused, similar to the work Imec is doing, on massively reducing the energy consumption. In terms of the talent pool, we've been fortunate. We've brought on a few very, very strong engineers into our team that are driving our programs. And we've been fortunate to engage with some very large lead customers as well that are helping us define our features and helping us through the development. I think that last point is very key for startups, especially in this space. Bringing a new innovative technology to market takes a village to make a chip. It's not a lone effort.
Absolutely, it takes a village. And perhaps this next graphic will give you a sense of what kind of a village it's taking to create this kind of a landscape, especially for R&D and for innovation. Now, after pharmaceuticals, the semiconductor industry invests the second highest proportion of sales to R&D among major industries. This graphic ranks the major chip producing markets according to R&D investment. The US and Europe invest the highest percentage in R&D. Now, Taiwan lands in third place, spending just over 10% of its sales on R&D. So, Mavis, we know that Imec is based in Belgium. It focuses on R&D. Can you tell us how else the company invests in innovation?
IMA has been the main force in Belgium, Flanders startup community. I think since 2018, we have spun off about, in average, 30 plus company each year and raised external capital of about over 350 million euro per year. I mean, in total to support those ventures. So we also have a separate entity called Expand, which usually act as the first VC for our ventures. And they became an external venture to Imec as well. So we have annual calls twice a year from all the collaborating universities and also IMA Research. So once the idea is selected, we stage gate them to business, and then we enrich them through 360 review and also assumption, validation. Then we time box them in RD and also venture. So when it goes well, we help them to prototype and build IP position and bring them to the next phase of execution and also the business plan, and then go to market strategy. So this is how we grow our innovation through this kind of an ecosystem.
Niraj, your company, Blumind, is venture capital funded and won the grand prize in the Innovex pitch contest in Taiwan last year. Other than that prize, what were you able to find in Taiwan's ecosystem for chip startups during your visit to Taipei?
Yeah, so my experience with Taiwan last year was really an eye-opener. So clearly, it's well known in my industry that Taiwan is a semiconductor leader, right? With the companies like UMC and TSMC based there, they've been innovating for a long time, and they've really made the foundry model the winning model in our industry. So that's very well known, and I expected to see that level of knowledge and talent on my visits to Taiwan last year. What surprised me a little bit was that there were also some very knowledgeable customers, system companies seeking to disrupt the industry. and they weren't as risk averse as maybe some other geographies tend to be with new innovative technology. So that was a bit of a surprise and really pleasant to see. I also saw a number of qualified deep tech investors that had a very deep knowledge of the semiconductor industry. If you're a VC that's investing primarily in SaaS type of businesses and ventures, it's, the semiconductor game is very different from that. So it's very important to work with investors that have an appreciation and understanding of our business. So I was really happy to meet a number of investors that fell into this category, and they've got a very global, worldwide view. So I found it very seamless working with folks from there and interacting from folks from there. So all of those things just helped. And then, of course, what I was not disappointed by were the ecosystem of semiconductor foundries, OSATs, system vendors, strategic partners, right? Taiwan has all of that in spades as well.
Right. To shed some more light on that, on your experience here, we spoke to Sakura Yang. She's the director of the Taipei Computer Association, or TCA, which organizes the startup-focused exhibition and innovation platform Innovex and Computex. That's one of Asia's largest tech trade shows. And she told us how Innovex supports foreign startups like Blumind.
So that's what we do for the startups, because for the semiconductor field, the government, like for example, the National Science and Technology Council, they organize TI award. So for the next step, they develop another 10 years programs to make the semiconductor industry more strong in the future. So they are trying to invite the semiconductor startups to come to Taiwan to help them to find the right partners, and also they give them support for the technology on the R&D side. So I think in the long term they can easily to find support from the government. Also, TCA can also provide good service for them.
Now, Niraj, while startups do have the advantage of agility and being able to move and evolve quickly, at the same time, they don't have that backing of that big organization or the bigger funding. So how would you say startups can grow to compete with the more established entities, whether it's in Taiwan or North America?
Well, I think startups really have to be very focused, right? And I think that's a mistake a lot of companies make. We're trying not to make that mistake. Is to be too broad or be unfocused on your target market segment and customers. And getting that early customer validation, to me, is extremely important, even in the semiconductor world, where your design cycle can take 3 to 5 years to get an innovative product to market. So it's very easy to veer off course and kind of drink your own Kool-Aid without getting the customer feedback and input to refine your product as you go along. So that's a really important thing you need to have. As well, as I mentioned earlier, IP is the bedrock of startups, right? If you're a larger company, you can actually go off and try and acquire IP to beef up your portfolio. As a startup, you don't have that luxury. So you got to have a really strong IP moat around your technology that differentiates you from competition, makes you attractive to customers and investors as well.
We're just about running out of time, but I want to give you the last word, Mavis. The startups, the chip giants we see today, like TSMC or UMC, 40 years ago, they were startups too. And they've evolved, of course, to become, basically synonymous for semiconductors. So my question to you to end the program is, what do you think we need to do for startups to help them be well positioned for the semiconductor industry of today?
Yeah, I think startup company, as Niraj says, that can be agile, can be pushing the envelope, really pushing the boundary. But a lot of time as you start, your first few years of survival rate, really, it's very risky and very questionable. So a company like Imec or a government in Taiwan, what can really help is to help them to really mitigate the risk and also provide them with an ecosystem that can quickly help them to validate their ideas, helping them to quickly get to the prototype stage. And for example, I think Taiwan government has done quite well, in my view, is there is a Taiwan Semiconductor Research Institute under NARS Lab. And what they do, they provide a cohesive range of verification services for semiconductor devices, circuits, and also system integration to really create an open platform for startups to leverage. Institutions such as IMEC and also other institutions in the world also offer a bridging services before a startup can get to a very large volume production. The small volume, the mixed load wafer processing can help them to reduce the costs to growth and help them again to reduce the amount of time required for the technology development, and also the verification really avoid resource wastage. So I think this really became an engine for startup to grow faster, quicker, and safer.
All right, we're going to have to leave it there, but not before I say a huge thank you to both of you. Mavis Ho, General Manager of Strategic Partnerships, APAC at Imec, speaking to us from Taipei, and Niraj Mathur, co-founder of Blumind, speaking to us from Toronto in Canada. Thank you both for being on the program. And for our viewers everywhere, it has been good to have your company. If you've enjoyed today's episode or have anything you'd like to add to the dialogue, do join the conversation on our YouTube and Instagram. And remember, stay informed, stay engaged, and stay connected.